Okay, we're going to start moving forward towards electricity, but before we do that, we have to learn a wee bit about atomic structure. Doesn't that sound fun? So we're going to talk about what an atom is. Maybe you've already heard this from baby schools, but that's fine. Here is a wonderful picture of an atom, and this one is not actual size. So you can see there's three types of things. You have the red in the middle here, you have the blue in the middle, and then you have these little blue ones on the outside. Now in reality, atoms don't actually look like that. You know, here's an artist's rendering of an atom. You can see there's all the stuff is kind of mashed together. And you have the stuff going on the outside, so this looks like a more stylized version. But let's talk about what those pieces are. So we've got three different parts that make up an atom. Well, at least we're going to keep it at this level so things don't get too quirky over here. We've got protons, neutrons, and electrons. So you have to know something about all of these. The protons are the positive one. What you have to know about protons is they are in the nucleus. Okay, the nucleus is this center region here. So let's label that. Okay, so the nucleus is the middle and the protons are in the middle. What else is in the middle? Well, the neutrons are in the nucleus as well. What isn't in the nucleus is the electrons. The electrons are outside the nucleus. Okay, so what does that mean? Well, they're in the electron cloud is what it's sometimes called. They're in the orbitals, it's sometimes called. You know, it depends on how you want to break it down, but they're on the outside, okay? Now, there's a couple things to keep in mind. Is the nucleus is very, very, very small, okay? So atoms don't actually look like the picture here. A real atom, if we drew it, you know, here's all the electrons going around, the nucleus is going to be smaller than that, okay? So most of an atom is empty. Okay, so a lot of the space around an atom is just empty between the electrons and the nucleus. 99% of it is just empty. Okay, to give you some sense of scale, if you had a football stadium that was the size of an atom, right? If an atom was the size of a football stadium, and then you took a marble and set it on the 50-yard line of the football stadium, that would be the size of the nucleus, generally. Okay, it doesn't matter how many protons or neutrons you have, it's not really going to start to interfere with the electrons because the electrons are way far away. Okay, so that is the first thing we have to understand. We also need to understand about charges. Okay, you can tell protons have a charge, they have a positive charge. Nice. Let's go to electrons. Electrons have a negative charge because, you know, they're labeled that way, you can kind of tell. And neutrons have no charge to them. They are chargeless. Okay, free of charge. The last thing we have to talk about is mass. So the protons have some mass. They've got 1 AMU. AMU stands for atomic mass unit. Just think of it as 1 proton's worth, okay? So an AMU is 1/12 of the mass of carbon-12, which has 6 protons and 6 neutrons, so it's basically halfway between them. Sort of, I'm lying to you a little bit, but not important right now until you take modern particle physics. So the nucleus over here the neutron has 1 AMU as well. So protons and neutrons are basically the same size. I mean, technically they're not, but they're very, very close, and it's going to be good enough for us. What you do need to keep in mind is that an electron has basically no mass. I mean, yes, it does have some mass, so we'll put an about equals to, and it's going to be around 0.002, was it 2 or 5? Whatever, we'll go with 2. I think it was 5. AMU. Alright, so basically it takes 2,000 electrons together to make one proton. So they're basically massless, okay? Now, how many would it take to make a kilogram or something like that? It would take a huge number, not important. So that is the basics of your parts of an atom, okay? So you need to know what the nucleus is. Why is that? Because we're going to be talking about how these particles behave under charges and electrical flow and all that stuff. So you have to know what's really going on. You also have to understand which ones have what charges, and you also need to understand how the protons and neutrons have all the mass, and the electrons have basically no mass. Alright. So what we're going to do is we are going to look at some elements here, and we are going to figure out what these numbers mean so we can derive the type of atom they have. Alright, so this is a chunk of the periodic table. Maybe these are called periodic chairs. I don't know. So this guy, this Li over here, this is the symbol. Nice. This is the name of the element. This one right here is the atomic number. The atomic number is special because this is also the hashtag of number of protons. Okay, so that's what's special about the atomic number, and it's important. It'll always be a nice number, like 3 or 4 or 5, and sometimes even 6. Alright, this number down here is called the atomic mass. Alright, this number will often be a decimal. But it will usually, now I'm saying usually here, it'll usually be really close to one number. Okay, so for example, this is basically 7. Alright, now why is it a decimal? We'll talk about that once we know what it stands for here. So this is the average number of protons plus neutrons. Okay, and that's what it is. So the reason why it's a decimal is because it's an average. Okay, so most lithiums have 7 protons and neutrons, but there are some lithiums that only have 6. And that will cause the atomic mass to be smaller than just a pure 7. Okay, and that's that. Alright, so things we're going to have to figure out, things you're going to need to know are you're going to have to figure out how many protons, how many neutrons, and how many electrons there are to this atom. Well, the number of protons should be easy. The number of protons is 3. Ta-da. The number of neutrons is going to be almost as easy because we know this number here, which is protons plus neutrons, is equal to 7. But we know protons is 3, so 3 plus something is equal to 7. What's that going to equal? Well, it's going to equal 4. Usually. Okay, now neutrons is going to be the one that changes because lithium is guaranteed to have 3 protons, so most of them have 4 neutrons. We're not going to worry too much about how some of them have other ones in this class, but you should be aware that it's the neutrons that could vary, not the protons. The protons are guaranteed. Alright, now for electrons, there are no other numbers on here. But here's the deal. Protons are positive, electrons are negative, and these two things have to be equal for a normal neutral atom. So if we have 3 protons, we are going to have 3 electrons for a neutral atom. Now, it is possible we have a charged atom, but we don't right now. We're just going to be neutral Nancy here. So that is what we are going to have. Okay, let's do another one. Let's talk about your friend and mine, aluminium. Okay, so let's see if you can figure out how many protons, how many neutrons, and how many electrons are had by this wonderful and unique element. You can pause the video to figure it out now. Did you do it? Let's find out. So protons comes from the atomic number. The atomic number is this nice number here, which is 13. Now, I know the electrons are going to be the same, so I'm just going to write that in right there. Now, how many neutrons? This number right here is basically 27. So there's 27 protons and neutrons. So minus the 13 protons is going to be 14. So there are 14 neutrons. So wonderful. All right, for this one, what we're going to be doing is we're going to be doing 2 things. So we are going to figure out how many protons, neutrons, electrons have, and we're going to draw the atom. So you need to draw and label the symbols for these. So for example, for protons, please do like a circle with a plus, because they're positively charged. For neutrons, make a circle without anything in there, because they have no charge. And for electrons, you can put a dot. I'm going to just put a dot, because they're supposed to be smaller. Okay, so please figure out how many there are of each, and then draw a picture of where each of them go. Alright, pause the video so you can do that. Finally, what took you? So, now that we're doing this, we're going to see protons, neutrons, and electrons. Protons are easy, there are 7. That will match the electrons. Neutrons, this is 14, so 14 minus 7 is equal to 7. There's 7 right there. So we are going to have 1, 2, 3, 4, 5, 6, 7. These are all your protons. Then we're going to have 1, 2, 3, 4, 5, 6, 7. Those are your neutrons, and then we're going to have 1, 2, 3, 4, 5, 6, 7. There's all your electrons. Your protons and your neutrons should be in the nucleus, right? You don't have to label it, but hopefully you remember that that's where they belong, and your electrons are not in the nucleus. Very good. You should have 7. Now, it's okay if you didn't draw your atom to actual size or to scale, because that would be very difficult to do. Okay, so we're going to add one thing here. This works the same for all of these beautiful and fun elements. Alright, so what we're going to add in this time is we are going to add in a charge. This will be the last one. I know you're disappointed. What about a charge? There's 2 kinds of charges atoms can have. They can have a positive charge or a negative charge. Now, if they have a negative charge, we're going to do this one first, means they have extra electrons. Okay, so extra electrons because electrons are negative, right? Electrons are negative because you have extra electrons, you have more negative stuff, you're going to have a negative charge. Now, if you have a positive charge, you are going to have fewer electrons. I want you to notice that protons does not change. Protons does not change. Right? Why don't protons change? Protons don't change because they're inside the nucleus and you can't get to them. All right? That is why. So you will never, ever change the amount of protons or neutrons you have unless you're doing a nuclear reaction. We're not doing that here. So bismuth right here, I'm going to tell you that bismuth is at a -3 charge. Okay? So I want you to figure out how many protons, neutrons, and electrons there are. You don't have to draw a picture of it, but you can if you really want to. So pause the video and see if you can figure out how many of each it has. Well, let's do this. How many protons does it have? It has 83. It will always have 83 protons. How many? Sometimes they do P plus for protons because, you know, that's the way it is. Let's do electrons. How many electrons does it have? Well, it would have 83, but it has how many? Some extra ones because it's got a negative charge. It's got 3 extra electrons. That means it has 86 electrons. How many neutrons does it have? Well, this is 209. I'm going to subtract my 83 from there. So I am going to get 126 neutrons. And that is how you figure that stuff out. So you need to understand how these particles work so that we can use them with electricity. So fun. Like and subscribe for more videos coming up.